Hi, welcome back, Introstat students. Today we're doing another exercise on in Unit 10 on sampling distribution in the lesson of sampling distribution of a sample proportion. And today the exercise is this, the mean and standard deviation of sample proportion. Okay, let's, uh, let's go. So, a safety A safety officer of a mining company takes an SRS. SRS stands for a simple random sample, right? So simple random sample is a sample taken so that each member and set of M members has an equal chance of being in the sample. Okay? So that's what SRS means. So everyone has an equal opportunity of being included in the sample. So SRS of 500 employees and finds that 15% of the sample employees wear contact lenses. The safety officers may take several more samples like this. Suppose it is really 12% of the approximately 34,000 employees in the company who wear contact lenses. So here, suppose it is really 12%, but in the SRS, in the simple random sample, only 15%, right, were found to have to wear contact lenses. So what are the mean and the standard deviation of the sampling distribution of the proportion of employees who wear contact lenses? So at this point, you need to understand something. That is, so they ask you for the mean. Now, the symbol for that is this. Mu is, we know that as an average, like a mean. If you write this subscript here, p hat, that means it's the mean of the sampling distribution, right? Mean of the sampling of the distribution of proportion, because there's a p here. And this should be equals to P. And what does P means? This is your population, right? This is your population proportion. Okay? And then the standard deviation has a symbol like this, sigma. And it also has this subscript of P hat beneath, right, next to it. And that has a formula of square root P times 1 minus P divided by N. Okay? So this is the two formulas you need to know. You need to figure out what the P is. So in this case, what is the actual population proportion of employees who actually wear contact lenses? The answer is right here. So it's 0.12. And if you use the actual P equals to 0.12, you substitute into your calculator or into the formula 0.12 times minus 0.12 divided by, what's my N? My N, interestingly enough, is 500, right? That's your sample. Okay? So some of you might struggle to do this on your calculator. And I'm going to show you. So 0.12 times 1 minus 0.12 divided by 500. So if you go to, you see the square root symbol here? So if you take second square root, and if you put 0.12, that's what you want, right? 0.12, that's your P. Times it by, put another bracket, 1 minus 0.12. Okay, but it's divide, right? Divide by 500. So it's point, actually, do we even need to work it out? No, we just need to know how to place it properly. So of all the options you see here, A, B, C, D, E, A has a mean of the sample the mean of the sample proportion is 0.12. And that is consistent with what we have been given here. We were told that the population proportion is 0.12. So as you can see, B is wrong, C is wrong, only, oh dear. So yes, B is wrong, C is wrong, only A and D is correct. But A and D use the N to be 34,000, but our actual N is 500. Okay? Right. Let's move on. A politician takes an SRS, simple random sample, right? Simple random sample of 75 citizens in a county to see what proportion of citizens sample are satisfied with their standard of living. Suppose that 80% of the 118,000 citizens in the county are satisfied with their standard of living. So now SRS, simple random sample. So your N is 75, but your true P, right, your true population proportion is 0.8, because suppose that 80% of the 118,000 citizens in the county are satisfied with their standard of living. Okay, so we're using 7. So there's a formula that goes like this. P hat that goes with P, right? That's the mean of the sampling distribution of the proportion, sample proportion. And we know that because this is an unbiased estimator, your population proportion should be the same as your sample proportion, right? The mean of the sampling distribution of the proportion. And that should be 0.8. And what is the standard deviation of the sampling distribution? We use this formula, right? We use the actual P. So it's 0.8 times 1 minus 0.8 divided by, what's my N? 75. So we don't really need to work it out, because as long as we can, the option, look at the options. We don't need to figure out what our actual standard deviation of the sampling distribution is. You just have to know how to use it. And it seems like this is it, right? The mean is 0.8, the sample mean. The mean of the sampling distribution is 0.8. And here we're using 0.8 times 1 minus 0.8 divided by 75. Okay, so hopefully this makes sense. I'm not going to do more. If you need to do more, if you have questions, please come and see me. Thank you.